Alright, so once you get to your main screen here, Google or type in the search workbench 17.2. Click that. It's going to take a second to load. Once this is all pulled up, we're going to want to do a fluid flow for a cylinder. There's 4 important steps for this flow around a cylinder. So once you double click fluid flow, the 4 steps are the geometry, this tab right here, then we're going to do a mesh, setup, and solution. So for starters, we're going to start with geometry. Right click geometry, go to new design, modeler geometry. For this cylinder, we're modeling an infinitely long cylinder, and we're going to be doing this flow for laminar flow. So to start, click this Z so we can be in the XY plane. Click XY plane, click new sketch. Go to sketching tabs, click circle. Make sure down here you're at 0, 0. Once you're at 0, 0, make the first circle, end it wherever you want. Give it dimensions, diameter. Or make the circle 1 meter in diameter. Once you do that, we're going to go up to this, we're going to make this a surface. So go to concepts and go to surface from sketches. And go back to the details view menu. You're going to want to make this sketch your details, your base object. So apply that to base objects. And then once that's done, click generate. And then you'll see that this is now a surface, it's gray. So now you're going to want to go XY plane, new sketch. Okay, now we're making the outer circle. So the outer circle is, the importance of it is so you have to make it large enough to where we're still getting all the fluid flow that's acting on the inner cylinder, but we're not affecting any of the flow that's acting on the inner cylinder. So we have to make the outer circle large. So we're going to make sure we're at 0, 0 again. Just make a circle. We're going to give it dimensions. We're going to make this a lot bigger than the other circle so it doesn't affect any of the flow. Details, we're going to make this 64 meters in diameter. Once this is done, let's see this outer circle. So now we're going to want to go back to this concepts and then surface from sketches, and we're going to make this a surface. Go to details. So now we're going to set this sketch to, and then the operation we're going to set it to frozen. Once that's done, click generate. This will also be a gray circle when you're done. Okay, next we're going to go to Boolean. We go create Boolean. We're going to go to details view. We got to set up the operation. We're going to do a subtract operation. So if you open up this 2 parts, 2 bodies tab, you're going to want to set this the second one to be the target body, and the first one to be the tool body. Once that's done, you're going to want to click generate. Okay, next step, we're going to click on the XY plane, and we're going to make another new sketch. You're going to create a line. So go to sketching, go to line. You're going to go to create a line that connects, that goes through the 2 circles. So have it start above and then make it go all the way down below. Make sure your X coordinate is at 0 when you stop and finish. Okay, from here, we're going to want to modify this line and cut out some of the parts. So we're going to want to modify, we're going to open up the trim feature, and you can just click the line that you want trimmed, and it'll trim that line. So up here, click it above the circle, it'll trim that part. Click it below the circle, it'll trim that part. That line still exists. Now in this inner circle, we're going to want to click on both sides. And now you can see once that's done that the line only in the outer circle exists. It does not exist in the inner circle. And then we're going to want to do now a line body creation. So you go to concepts, lines from sketches now. And we're going to want to set the base object to sketch 3, which is the line that we just drew. Apply that. And from once that's done, click generate, put it in effect. All right. We're now going to go up here to tools, click projection. And we are going to apply the edges. So if you go up here, click edges, we're going to make these lines the edges. So if you hold control, you can select both of these lines. And apply that. Once you do that, you're going to go here to target, and the surface body, you're going to apply the surface body to be the target. And you have to actually click on the surface body and then apply that to target. Once that's done, save or generate, click generate. You can see now the inner circle is not gray because it's not supposed to be, and then the outer circle is gray. And then what we can do from here, you always want to make sure you save so you don't lose your work. We'll save this as cylinder. Save that. All right, now once that's saved, we're going to go on to kind of the next most important step in setting up this cylinder, and it's the mesh. So you can go back to this main page right here. Once we set up the geometry, and we now got to set up the mesh. So we're going to want to double click mesh right here. It's going to give us a little pop-up window, or no, it won't. It won't give us a pop-up window. It's just supposed to pull up here in a sec. Alright, now you can see this is our geometry that we made in the previous section. So we're going to want to right click mesh, insert, and then we're going to want to do a face meshing. So we want to set now the geometry for the face meshing. So once you do that, you just want to hold control, set both halves of the outer sphere to be the geometry. You want to click apply. You'll see right here it says 2 faces. And then once that's done, click update. Okay, turns it purple. Next, we're going to want to do some edge sizing. So right click mesh, insert, sizing, and now we're going to want to set geometry to both edges of the surface body, so not the faces, but just these edges right here. If it won't let you select the edges, just go up here to this little cube that has an edge on it. Click that. You're going to want to hold control to select both of them, but select one, then the other. Then you're going to want to go back to this pop-up window and apply those. It'll say 2 edges right here. Once you do that, you're going to go down here. You want to go to set type of divisions. Well, we want to set this type to the number of divisions and not element size. So if you double click that, it sets it to number of divisions. And now we got to tell it how many divisions we want to do. We're going to set that into 96. Then the behavior, we're going to double click that, set it to hard. And once you did all those, click update. All right, next we're going to want to do, kind of doing the same thing over and over again. We'll go insert sizing. And we want to just set the top half of this line right here. We want to choose that right here and set that to be the geometry in our case. So just that one edge. We're going to want to set type to number of divisions as we did last time. We want to again set the divisions to be 96, set the behavior to be hard, and set the bias type. We're now going to want to do a bias type, and we're just going to keep it in this first option right here. And the bias factor, we want it defined to be 460. Once that's done, you're going to want to go back to mesh, right click on mesh, insert sizing. So now we're going to do the bottom half of this line. So click that, set that to be the geometry. And we're going to want to pretty much do the same process. Want to go to type to be number of divisions. Again, so the divisions to be 96. We want to set the behavior to hard. And we want the bias type now. If you double click this, it'll set it to be the second option, which is what we want. And then the bias factor, we want to set to be 460. All right, once that's done, I'm going to right click mesh now, and then click update. And you can see the mesh. And if you can see, there's like a lot more elements closer to where our cylinder is. That's because we want to model the flow around our cylinder, and that's where the flow is changing the most. So that's going to give us a more accurate prediction. All right, so once we finish this mesh, we can check to make sure it's right. So we can click mesh, and then once you click mesh, you can go here to this plus, expand the statistics, and you should have roughly this many nodes and this many elements. Once you know, looks like it's correct for you, then we want to name some of the boundaries in this so we can refer to them later when we're setting up the solution. So click model A3 out here in your little schematic tree, and then we're going to want to select just the right half, or the left half right here of the cylinder. Right click, you can create the name selection for that. We're going to call that far field 1. Okay, we're going to do the same for this half. So click, right click, create name selection. We're going to do this one, far field 2. Okay, and now for the inner circle, if you hold down the control key, you can hit both edges of the inner circle, right click, and we're going to name this one cylinder wall. Click OK. And then once you name all those, you can go double check to make sure they're all right by expanding this, checking that one's called far field 1, the right side is far field 2, and then the inner cylinder is cylinder wall. All right, so once you can do that, you can minimize this. But make sure you want to right click mesh right here before you do anything else, and then click update. All right, so next, after we do mesh, save the project, and then we're going to set up all the solutions. So double click solution, or double click setup, sorry, and then in this little pop-up window, make sure you click double precision to be an option, and everything else can stay the same. And once you make sure you did that, press OK. Should pull up a new window. And this, you can see our mesh turn green. So we can go to mesh. Up here in this term, or in this tab, we can kind of check stuff. So we can go to mesh, and then info, and then click size. And then down here in our little pop-out window, we can make sure we have about 18,432 cells. And then we can go to check. And if it runs without any errors, which it did, then we're all good to go to continue. Once you do that, we're going to specify some material properties. So go to setup or materials, and then fluid, and then create /edit. We're going to set the density to be 1 kilogram per meter cubed, and the viscosity to be 0.05 kilograms per meter seconds. Once you do that, click change/create, and you can click close. And once that's done, you want to specify the model. So go to setup, models, viscous. We're going to make sure it's laminar because we're doing a laminar flow. You can edit it and make sure that laminar is the only one that's picked, which is what needs to be done. Close that window. That's good. Next, we're going to specify some boundary conditions. The reason why we're doing this is that's the only way the problem can be solved. If we didn't have the boundary conditions, there would be too many unknowns, and we wouldn't really get a solution out of this for a specific boundary condition. So we're going to set the boundary conditions. Click this. We're going to click far field 1, and then we're going to set the type of this boundary condition to be a velocity inlet. So scroll on this tab until you see velocity inlet. It's right here at the bottom. And you're going to want to set the velocity specification method to components. We are going to set the x velocity to be 1 meters per second, and the y velocity is going to be 0. Click OK when you're done. Alright, so now we're going to want to set up the far field 2. So in this same tab, just click far field 2. We're going to set this to be a pressure outlet. And then you don't have to do anything right here. You can just press OK. And then the last boundary condition we're going to do is we're going to set up we're going to determine what the cylinder wall is. So we're going to set the type to cylinder wall to be wall, which it already is, or keep it as wall. And then that's all you have to do here. So you can just exit out. And then we're going to have to reference values. So if you go to problem setup, setup, and then reference values, the tab right here, we want to compute from far field 1. So the flow is going to be moving from left to right. We're going to check density, 1 kilogram per meter cubed, which is what we want. Viscosity, 0.05 kilograms per meters per second, what we want. And then velocity is 1 meters per second, which is what we want. So now what we're going to do is we're going to set up the solution and run the calculation. So under the solution tab right here, click solution methods. And then you're going to want to go to spatial discretization. And then set momentum to be second order upwind. All right, you can see it's already the correct one. So we can be done with that. And now we're going to go to solution monitors, and then residuals right here, would make sure that one's clicked, and then click edit. We're going to set absolute criteria for continuity. We said that, so that's good. And we want to set x velocity and y velocity to 1 times 10 to the negative 6. So we're going to do 5 zeros here and a 1. 2, 3, 4. wait, I can't count. 1, 2, 3, 4, 5, 1. And then, and make sure you also set this continuity 1, 2, and times 10 to the negative 6. Once that's all done, you're going to press OK. All right, now we got to kind of set up our initial guess. So go to Solutions and Solution Initializations. Go to Standard Initialization, and then Compute from Far Field 1. And then you can see the X velocity is already set to 1 meters per second, which is what we want. Once that's done, click Initialize. All right, now we're going to run our solution. So go to Solution, Run Calculation, right here at the bottom. We need to set our number of iterations. We're going to set it to 2,000. And then once that's done, click Calculate. And you actually have to click it twice sometimes in order for it to work. And you got to wait for a little bit. All right. So our calculation completed. And we can see our solution converges around 651 iterations. So if yours converges around there, you probably did it right. Okay, so now we'll look at some of our results. We go to Reports. You're going to want to go to Forces and then Setup. So these are the result reports. Forces, Setup. And then what we're just going to want to do is click Print. And we can see, you can exit out of here and expand this window. And see that this 2.04 number is what we get for our drag coefficient. And so if your number's around there, you probably did it right. So yeah, so that's how you do a fluid flow around a cylinder, an infinitely long cylinder, laminar flow. Thanks for watching. We'll see you back next time.